Hi everyone, it's Miss Berry. In today's video, we're going to go over section 6.4. We are going to need our calculators again, so make sure you get yours out. And I'm going to go ahead and share my screen and we'll get started. Okay. All right. Oh, let me go back and mute my camera. Okay. Okay. So this section is called finding values of a normally distributed random variable. So we are still working in the normal distribution. The only difference here to what we've been doing, which is calculating probabilities, is this time we will be given probabilities and we will find the X value. All right, so we're just sort of doing the opposite of what we've been doing. All right, so in the past, we've been given information about a probability distribution, and then we were asked to calculate probabilities. But in this section, it'll be the opposite. We'll be given the probability, and then we have to determine that corresponding z-score or X value. All right, so same thing, just different ways to refer to that value. You could call it a z-score or an X value. All right, so here's our first example. It says, find the value of z. Okay, we see the variable z. That tells us that we're in the standard normal distribution. All right, so variable z tells us that we're in the standard normal distribution. All right, so find the value of z such that 0.13 of the area lies to the left of z. All right, so 0.13, that's the probability or the area under the curve. Let's go ahead and put our little mark in the middle for our mean. We are in the standard normal distribution since we see that variable c, which tells us, or did I say c? I meant to say z, sorry. We're in the standard normal distribution, which means that our mean is 0 and our standard deviation is 1. So we're going to put 0 in the middle. And it says that 0.13 of the area lies to the left of z. All right, so think about that this curve, 0 is splitting this curve in half. So this is 50% and this is 50%. All right, if 0.13 of the area lies to the left of z, let's see, if this is 50%, maybe this is about halfway. That would be 25% on in each one of these parts. And then even further over to get to 0.13. All right, so we'll shade in this little tail and say, okay, we're saying that's 0.13. And it lies to the left of z, so we're going to say that that's z. Okay, let me just erase all this other stuff. Okay. All right, so now we can grab our calculator. All right, so let me pull up our calculator. Okay, let's clear everything out. Right now, I'm going to go to second vars. So the same place that I've been going to get the normal CDF, I'm still doing the same, clicking the same button. So second and then the vars button. And then I'm going down to option 3. I've been using option 2. Right now I'm going to use option 3, which says INV norm. That means inverse norm. All right, and so then it's going to pull up this second menu. It says area, mu, sigma, tail. All right, so the area, that's the area that's shaded. That was 0.13 or 0.13 if you could put the 0 in there if you wanted to. All right, and then mean is 0, standard deviation is 1 because we're in the standard normal distribution. And then for the tail, you got to tell it which side you have shaded. And we've got the left side shaded, so we're not going to change anything there. It was already highlighted on left. If I wanted to change it to right, I would just toggle over or arrow over to right and then hit enter. That would change it. All right, but I'm going to keep it on left. Then I'm going to hit paste. Again, this just pastes that command onto the home screen, and then you're going to have to hit enter to run it. And there's our z-score or our x value. So we'll do 2 decimal places on these, negative 1.13. All right, so we're saying that our z value here, z value, oops, let me switch to a pen. Okay. Our z value is negative 1.13. Now, when I see this value, I think that makes sense because this number was to the left of 0. So I'm expecting it to be negative. All right, so I'm expecting that value to be negative. So that negative makes sense to me. All right, let's try another one. Very similar. Find the value of z such that 0.01 of the area lies to the right of z. That's a really tiny, tiny area. All right, so again, we see that variable z. We know we're in the standard normal distribution with a mean of 0 and a standard deviation of 1. All right, so I'm going to put my mean in the middle, and I've got 0.01 of the area lying to the right of z. All right, so again, if we looked right there, this would be half and half, 50%, 50%, or 0.5, I should say, I guess, if we're trying to be consistent with how they're writing the probabilities. All right, so 0.5, 0.5, half, another halfway would be 0.25. And then this is super, super tiny. So we're just going to shade right in the tail there. All right, I'm going to erase all my lines. Just shading right in the tail. And I'm going to draw an arrow and put that's 0.01. And then here's my z value, my z-score. I'm expecting this to be a positive z-score because it's on the right-hand side of the curve. It's to the right of 0. All right, so let's go back to our calculator. Clear everything out. Always start with a clear screen. We're going to second vars, go down to inverse norm. All right, this time our area was really tiny. It was 0.01. Mean was still 0, standard deviation was still 1, but this time we have the right tail shaded. All right, and then hit enter, and then run it. And there we go. 2 decimal places would be 2.33. 2.33. Okay. Next, we have an in-between problem. It says find the value of z such that 0.516 of the area lies between negative z and z. All right, so there's our area. 0.516, that's a little over 50%. So we're putting the mean 0 in the middle. We know our mean is 0, our standard deviation is 1. And so it says it's in between these two values, negative z and z, and this shaded area is 0.516. Okay, let's jump back over to our calculator, clear everything out. All right, go to second vars, go down to inverse norm. All right, this time our area was there we go, 0.516. All right, 0.516. Mean is still 0, standard deviation is still 1. This time we've got the center shaded. So we'll highlight center and hit enter. Then go down to paste and hit enter. That's going to put it on the home screen. Hit enter again to run it. And there's our little z-scores. 2 decimal places would give us negative 0.7 and positive 0.7. All right, so negative 0.7 and positive 0.7. Sometimes on your homework, they might just want you to enter the positive. So maybe they may only want the positive z-score. But if you have any trouble with that, you can just email me and send me a picture and let me know. All right. So now we're going to get into the problems where we're not in the standard normal distribution. Here are some word problems that you might see. It says, suppose the ACT math scores are normally distributed with a mean of 18 and a standard deviation of 6. All right, so mean is 18, standard deviation is 6. A university plans to award scholarships to the students whose scores are in the top 7%. All right, so top 7%. What is the minimum score required for the scholarship? Round your answer to the nearest whole number. Okay, so here's our normal curve. Put your mean right there in the middle, 18. And we're looking at the top 7%, so that's going to be people that scored higher than average. Right, so we're shading the top or the right-hand side of our normal curve. And as a decimal, 7% would be 0.07. Right, so that's 0.07 is the probability or the area under the curve. So now we've got everything we need. We know that our mean is 18, our standard deviation is 6. Let me switch to my little laser. We know that our mean is 18. We know our standard deviation is 6. We know the area under the curve is 0.07. And then we know it's shaded on the right. All right, so let's put all that in. Clear this out. Second bars. Go down to inverse norm. All right, 0.07. Mean was 18. Standard deviation was 6. And we're shading in the right tail. Okay, when you're ready, go down to paste and hit enter. And then run that. And there's our score. We're supposed to round this to the nearest whole number, so this would be approximately 27. All right, so let's write a little sentence. What is the minimum score? So minimum score is approximately, what do we say, 27? Yes. So if you want to get the scholarship at this particular college, you're going to want to score a 27 on the ACT math. Okay, last question. The lengths of stay for emergency patients at a hospital are normally distributed with a mean of 19 hours and a standard deviation of 5 hours. Okay. Find the two lengths of stay that separate the top 4% and the bottom 4%. All right, so here's a little normal curve. I was about to draw one, but I forgot I already had one lined up. All right, so let's switch to a different color. I've been doing purple this whole time. Okay, so we're going to put our mean in the middle, 19 hours, and we're looking at the top 4% and the bottom 4%. So shade in, shade in. So this is 4%, this is 4%. Now, there's two ways you can do this. You're going to have two values that you need to find. So we'll call this like Z1 and we'll call this one Z2. All right, so we're going to have two values that we need to find. The first way that you can do this is just to do it in sort of like two different steps. So the first step, step one, would be to find Z1. And then you would, go to your calculator, go to second bars, go to option 3, which is inverse norm. And then you would only be focused on this one. Okay, so you could do that. Let's try that. All right, so clear this out, go to second bars and inverse norm. Area is 0.04. Mean is, we said 19. I forget the standard deviation. It was 5. Standard deviation was 5. And we have the left tail shaded. That was Z1, was that Z-score on the left-hand side. Then paste. Did it say it around to the nearest whole number? It doesn't say. Let's just do 1 decimal place. We'll say 10.2. All right, so Z1 is 10.2. That value makes sense. Oops, accidentally erased the 9. There we go. That value of 10.2 makes sense given that it's to the left of 19. It should be smaller than 19, so that it makes sense in that context. Now you're just going to go back in and do the exact same thing, but for Z2. All right, so you're going to go over here. That would be step 2, would be to find Z2. So you would do the same thing. Go to second vars, go down to inverse norm. All right, so let's do that. 0.04, this time to the right. All right, so everything's going to stay the same except for this time we're going to shade the right tail. But the area under the curve stays the same. The mean stays the same. Standard deviation stays the same. We're just changing that to the right tail. Go ahead and paste that, and there we go, 27.8. 27.8. All right, so if we were to interpret this in the context of this problem, you would say, okay, the 2 lengths of stay that separate the top 4% and the bottom 4% are 10.2 hours and 27.8 hours. So that would be like the what's like the most extreme case for both scenarios, that you're only there for a little bit and that you're there for a long time. So think like 27.8. That's more than a day. That's more than a whole day. All right, now, so I told you there's 2 ways you could have done this. The other way is that you could have found the area in between instead. This may be easier. I don't think there's that either one of them is particularly easier than the other, either method. But what you would do here is you would say, okay, well, this little tail is 0.04. This little tail is 0.04, so that's 0.08. I know that the whole area under the curve has to add to 1. So I would say 1 minus 0.04 minus 0.04. Let's see what's left over. 1 minus 0.04 minus 0.04. 0.92 would be in the middle. All right, so, sorry. There we go. 0.92 would be the area in the middle. So then you could go to your calculator and clear this out. You could do second vars, inverse norm, and then just do 0.92 in the center. You should get the same values. Okay. Enter. Yep, 10.2 and 27.8. Perfect. Okay, let me switch back to my my little camera thing here. Okay. So that's everything for this video. If you have any questions about chapter 6, that was the end of chapter 6. So if you have any questions about chapter 6, I hope you will let me know. Otherwise, I'll see you guys in the next video.